Today in my van build series, I'm going to be walking you through my electrical system. In order to do that, I wanted to talk about the original design criteria. I've been mountain biking camping, since about 2016, traveling to dozens of places all across northwestern North America. And what I've found is, typically I'm only boondocking for one night, sometimes 2 nights, rarely 3 nights, and virtually never 4 nights, because I'm hopscotching between trailheads from here to there. My criteria for my electrical system was to be able to boondock for up to 3 nights. So I needed to size my battery system for 3 nights of capacity. And I have a very simple van plan. So all I'm going to run off my electrical system is primarily a fridge, which I'll show you right here. So here's the fridge. It's a fairly large one. It has 3 days worth of capacity. So off the battery, I'm running my fridge, a water pump, a fan, and some lights, and an auxiliary jack that I can plug into some AC drills and coffee makers and the like in the rare time that I use that. So I have pretty modest loads. I don't have an air conditioner. I'm not heating water or anything like that. So when I add up all the load, I think what I use on a daily basis is somewhere around 600 watt hours a day. So I looked at some power packs. I didn't want to go through a whole custom build of an electrical system. I wanted something that I call plug and play. I was looking at some of these battery stations that have inverters, charge controllers already embedded in it. So I looked at the Bluetti, I looked at the Yeti, I looked at a number of the other new emerging ones. So 2 years ago, I bought the Bluetti AC 200P power station. I thought that would give me the full 3 days at a trailhead. If I have a 600 watt hour load per day, that gives me 3 full days of battery capacity and a little bit of wiggle room if the loads are maybe a little more than I expect. The electrical system componentry comes down to 3 fundamental things: the amount of input to charge your battery, the amount of battery capacity you might need while you're boondocking for like those 3 days, as well as the total load. So with the plug and play, my plan was simply to plug in the battery into my 12 volt DC port. And what I found is, unfortunately, it only recharges at a rate of 100 watt. So it would take 6 full hours to recharge the 600 watt hours that I use overnight. So I have 2 ways of charging my battery. One of which is by charging it directly into the 12 volt DC port. And I also have some portable solar panels that I can put out in a pinch when I'm not driving my vehicle. Solar panel deployment is a little bit of a hassle because you gotta plug them all in. You gotta lean them against the ground. Sometimes you're in a dirty area, sometimes there's shade and so on. So solar panels are not always easy to deploy. I didn't want to put holes in my roof and install them on the roof. I didn't think I was going to need solar panels all that much. So I was planning to rely on the 12 volt DC port. So I found I've had to deploy my solar panels way more than I want to. And usually when you put your solar panels out, it's in the core hours of the day. Those are hours of the day that I want to be riding my bike, not sitting around the trailhead waiting for my battery to get recharged on the solar panel. So I wanted to find a way of enhancing the charge rate of the battery off of my car alternator. So let me take you on a quick walkabout of my system that's in place right now. So I've installed a 12 volt DC port here at the back door of the van, and it plugs right in here, and the wires go up here along the wall out to the middle of the van where my battery is right here. So let's walk around the front. And so that's where I have the battery underneath the bed, right in the middle here. And the power comes in here, charges the battery, and this is the output from the battery to a fuse box right there. So I've run a number of wires to all the different loads. I've got the water pump switch here. I've got the light switch here for the lights over the bed, as well as pocket lights in the roof. I've got a rooftop fan, and I've got an auxiliary jack for some AC power here. And there's my fridge. So that's the system I have in place now. And so as I mentioned, that I'm only getting 100 watts of input charge back to the battery, and I'm finding it's not enough. So I've been trying out something. So I have a battery to battery DC charge booster that takes the voltage from 12 volts to 48 volts, and in which case it now charges the battery at a higher, recharges at a much faster rate. And so let me show you how I'm going to do this. On the side of the driver's seat is the customer connection port down here. It's got a plastic cover that you can take off, and so you can see that it has two connecting terminals here. They call them the customer connecting port. So this port, CCP1, is 60 amps. CCP2 is up to 170 amps. And so I'm using this one because this port is connected to the ignition switch. My house battery isn't going to draw charge from the car if it's not on. And I've tested it out, and I noticed that with this port, it switches off after a delay of about 10 minutes after I turn the vehicle off. So let's demo this out and see how it's going to work. So I have two 15-foot long 6-gauge cables coming from the customer connection ports. They're going to run along the wall back underneath my bed and connect into the battery back here. But I've taken the battery out so I can do a quick test to validate that this concept is going to work. So from the customer connection port, I'm going to run the power along these cables. I'm going to install a switch here so I can turn it on and off. I've also got a 40 amp breaker here, and it's going to come into the DC booster here that's going to ramp the 12 volts up to 48 volts. And then the power is going to come back into the battery here and charge the battery. So let's turn this on and see what it does. So using my simple voltage meter, let's see what this is doing here. So that's 12 volts there as it runs through the breaker, comes in here, and on the output end now it's 49 volts. So that's the 49 volts that's going to go into here. And let's see if we turn our battery on. And so now with the engine running, I'm getting a charge of 566, 68, 66 watts on my Bluetti power pack. It's going to be about 5.5 times the rate of charge from the 100 watts I was getting on the 12 volt DC auxiliary port to what I'm now getting off of this device. But I am concerned a little bit about how hot this thing is going to get in extended use. So I'm going to test that out as well. But in concept, for me to get the 560 watts here at 48 volts, that's going to be about 12 amps or something like that. So that means that I'm drawing about 4 times that off my DC customer connection port, or somewhere around 50 amps from my car alternator. So you got to make sure that your car alternator capacity is going to handle that much drain off the battery so that it doesn't jeopardize your ability to start your vehicle. I bought this van with 2 batteries. They're both under the seat here. And so there's the starter battery plus there's an auxiliary battery, which is what this is connected to. And so after running this for about 30 minutes now, I've noticed using my cooking thermometer that this heats up to about 140 degrees Fahrenheit. So it does get pretty hot. I'm planning to install a fan that's going to be connected to this, so when it's on, it's going to have a little bit of breeze blowing across it. So that's not part of my system yet, but the idea here is that all these componentries that I've tried out here now, I'm going to install in here under the back of the bed. I've also validated that after turning off the car like that, if I wait about 10 minutes, you see it's still drawing power. Got 430 watts right now, and after about 10 minutes there's a noticeable click to the ignition system underneath the seat, or somewhere in the front end here. There's a noticeable click when the draw off the car battery shuts off after about 10 minutes. So I think I've covered all the bases. So here's a quick update on my DC boost charger install. And so here's what it looks like here with the on-off switch, the breaker, the cables coming from the customer connection port on the off of the driver's seat, and the cables running up along the wall, back behind the wall here. And so the cable comes out from back here, runs into connect into the boost charger here, and you can also see, hopefully, that I've got a fan on the front here to keep it from cooling. So it's driven right off the power outlet here as well. And I also decided to add an additional 12-volt auxiliary port right here that I can plug in a heating blanket to here and use this dial to tune in the amount of power that's going to the heating blanket. As I've mentioned in a previous video, I don't have any heat in here, and that was by intention. But in order to keep it reasonably warm on a cold night, I'm going to use this with a heating blanket. So that's a quick rundown on my electrical system. My needs by intent are pretty modest, so I can get away with this Bluetti power pack device, which completely simplifies my electrical needs. So it's pretty much a plug and play concept. You buy the battery, you plug it into, in this case, you plug in a 12 to 48 volt boost charger that's run off your car battery directly into the solar port of the Bluetti power pack, and then your output goes directly into a fuse box that distributes your load among all the different devices you're going to ride in-house. It makes electrifying your van a very simple thing to do for a do-it-yourself guy like myself. So anyway, folks, that's enough for now. Stay tuned for some other components of my van build as I build this out. So my concept of my van build was to do it in stages, and at each stage try out how it worked. And what I found over the last 18 months of building this is there was many refinements that I discovered. So I did take the garage apart, I redid the cabinets, I redid some of my electrical components and so on to fine-tune it into a much better version. I wanted it to be a very simple van build, but I also wanted it to be elegant so that I didn't have to fuss with things that were annoyances that I was going to end up regretting. I wanted it to be really simple and trouble-free. So that's all for now, folks. Thanks for watching, and we'll see you next time.